So in order for cells to have muscle contractions, in order for cells to do any work, they actually need to have what we call an action potential. An action potential is that electrical signal that allows for the muscles to release certain materials. So this is what an action potential looks like on a graph-like level. So an action potential then, the first portion that we talk about is the resting membrane potential. Resting membrane potential is minus 70 millivolts. That means that the cell has potential to do work. It's a little bit like your little brother pulling back a rubber band and about to shoot you. At the point where he's pulled back the rubber band, he's not really going to shoot you yet. He has the potential to do that, but not yet. That's the potential for the cell to do work. Okay, then what happens is sodium begins flowing into the cell. We call that depolarization. As sodium flows into the cell, it makes the cell less negative. When we reach this point of minus 55 millivolts, we now can have an action potential. So the action potential will happen. At this point we call it all or nothing. You are either going to have an action potential or not. As we reach 0 millivolts, there's no going back. We're going to reach 30 positive millivolts. That's an action potential. Now potassium begins flowing out of the cell. We call that repolarization. As it flows out of the cell becomes more negative again until it reaches this point. At this point, we call it the negative after potential. At this point, if we get another signal from a nerve, we can have another action potential because the cell is very hyperexcitable and can have another spike. At this point, though, we call it the positive after potential. The cell is hypoexcitable. There is no way you can have another action potential at this point. And at this point, then, the sodium-potassium pump turns on and reestablishes balance in the cell, and which eventually will bring it back up to minus 70 millivolts resting membrane potential. And this is what happens over and over again, which allows signals to take place. So for instance, in our brain, many neurons will get together and they are all having sodium flow out until you have a large enough spike that you're going to have an action potential. And then it will cause other things to happen. Muscle contraction, move your arm, glands to produce things, etc. So this is the establishment of all things in our body for doing work, action potentials. They're very important for muscles, they're very important for the nervous system, for signaling from one neuron to the next.